All right, so we've created our volume noise, and now it's time to actually advect our particles by this volume. So I'm going to turn this off because we don't need to visualize it anymore. I'm going to go into my particle sim, and under our pop source node, I'm going to create an advect, pop advect by volumes. There we go. You can type advect and that'll come up. And now let's look at our options here. So I'm going to drag over our viewport and see what we've got. First, where do we want our velocity source to come from? We want it to be from a SOP. So we have a field to go grab that SOP. So we will go to our volume noise and grab our out null. And a bunch of different options here. The main thing we want to do is just have a vexpression driving how this affects our points. Because similarly to what we did with the pop wind in the sprites chapter, we want to do sort of the same thing here, because when the particles are birthed, we want to have very little effect of this noise, but then over time we want to fade in the effect so that noise is going to move those particles more. So we can get the initial part of the stream really clean off our object, but then have it get sort of more languid and organically beautiful. So right now, if I were to press play, number one, you can see this is also quite a bit slower, because once we're generating that volume and then we're advecting by this, depending on the resolution of that volume, this can start to make things a bit slower, and the results are going to be worth it, but it's just something to know. So if I were to now hit stop, rewind, and mute this node, you can see that everything is going to move quite a bit faster. And if we went and changed the resolution of this volume, this simulation would run a bit quicker too. But this resolution works pretty nicely for our final result, so we'll leave it. Okay, so what we're going to do here is we're going to go back to our pop advect by volumes node. We're going to turn on the vexpression field, and this is what I'm going to do. We've got a velocity scale attribute here. You can see it's called vel scale under the hood. So we're going to type vel scale multiply equals, and just do the old fit01 expression. So fit01 at nage, comma 0.2, and then 3. So we're going to start off very subtle, just 0.2 of the noise being multiplied in, but over the length of that particle, it will actually end up be multiplied by 3. So it's quite a big range over the course of its life. All right, so now, for example, if I go back up to the volume noise and I go inside there, let's go to the fluid source. Let me change the division size to 1, so it's considerably less voxels. If we middle mouse click, we can see that's 2,744 voxels versus at 0.25, this is 125,000 voxels. So obviously we're in 3 dimensions. We get exponentially greater as we go. So just for a little preview though, let me pull this down to 1. Let me go back to our particle sim, and let me pull our viewport open just a little bit here and hit play. And you can see that already this is running faster just because we have less volume that we're sampling. But we can see we're starting to get some of this nice curl noised influence, kind of watery dissipation of these particles over the course of that life. And that's going to give us some really beautiful trails down the line. All right, I'm going to rewind that to the beginning. I'm going to go up and I'm just going to set that back to 0.25 because that's what we actually want here on our fluid source, division size here. And now we're going to move on to keep tweaking our particle simulation.